Okay, here we're going to be looking at the difference between power models and exponential models, and then we're going to look at how we can come up with the solution or with a function just given coordinates and a graph of a function. Okay, so firstly, power models have the general form y equals a times x to the power of m, where a and m are both constants. Now notice when x equals 1, y equals a times 1 to the power of m, and of course 1 to the power of any number is just 1, which means a times 1 is just going to be a. Furthermore, when x equals 0, y equals a times 0 to the power of m. Now this equals a times 0 for m being greater than 0. Okay, so we have two conclusions we can make from this point. Okay, firstly, that is all power models pass through the point x is 1, y is a. Okay, that was shown here. And that if m is greater than 0, a power model will pass through the point of origin. However, if m is less than 0, the model is asymptotic to the axes. Okay, and what that means is, like in this function here, it doesn't cross the y-axis or it doesn't cross the x-axis. There is an asymptote on the x and y axes. Okay, exponential models have the general form y equals a times b to the power of x, where a and b are constants. Now, notice that when x equals 0, y equals a times b to the power of 0. And of course, any number to the power of 0 is just 1. So when x is 0, y is a, which means all exponential functions pass through the point x being 0, y being a. Fantastic. So these are key characteristics we need to know about these two types of functions. Down here we have a function, and we want to determine what type of function it is first and how to write it as a function. All we're given are points and a graph of the function. So just looking at it, we want to discover if it's a power model or an exponential model. Okay, so we ask ourselves, does the model pass through the point of origin, 0, 0? The answer is no. Is the model asymptotic to the axis? Well, yes, it does appear to be. Okay, it appears that they just go that way forever and up the y-axis forever as well. Does it pass through the point 0, a? Well, it doesn't cross the y-axis, so no, it does not have a y-intercept. So what we're going to do is we're going to say this is a power model. So we're going to start with the general form of a power model, which is y equals a times x to the power of m. And we're just going to start putting these values 2 and 2 and 4 and 1 into this equation. Okay, so when y is 2, x is equal to 2. So we have a times 2 to the power of m. When y is 1, x is 4. So we have a times 4 to the power of m. Here we have two equations, okay, and all we need to do is solve these for a and m. Okay, now the way we're going to do that is express them in terms of the other. So from equation 2, okay, this one here, we can determine that a is equal to 1 divided by 4 to the power of m. Okay, all we've done is move this 4m to the other side, okay, by dividing both sides by 4m to make a by itself. Okay, now that we have a by itself, we want to put this value into equation 1. Okay, so we're putting this right in there. Okay, so what we have then is 2 equals 1 on 4 to the power of m times by 2 to the power of m. Okay, so this is equal to 2 equals 2 to the power of m on 4 to the power of m, and here's where we start using our indices laws. So we have 2 is equal to 2 on 4, and inside of brackets to the power of m. And of course 2 on 4 can just be expressed as 1 on 2. So let's write it like that. So we have 2 is equal to 1 on 2 to the power of m. All right. And now let's expand it again. I'll do that just to show you what we're doing. We've got 2 equals 1 to the power of m on 2 to the power of m. And of course, 1 to the power of m is just going to be 1. So we have 2 equals 1 on 2 to the power of m. All we've done there is 1 to the power of m is just 1. Okay. Now, 2 to the power, 1 on 2 to the power of m can be expressed as 2 equals 2 to the power of minus m. Okay, so we've just changed that from here to here by our indices laws. And of course, 2 by itself is just 2 to the power of 1, which means minus m equals 1, which means m equals minus 1. Okay, so we've solved for the value of m. Now we need to solve for the value of a, and a equals, from this equation up here circled in red, 1 on 4 to the power of m. So a equals 1 on 4 to the power of minus 1. Okay, which is just 4 to the power of 1, which is 4. Okay, so we've determined these values for a and m. So then to write the solution in general form, we have y equals a, which is 4, times by x to the power of m, where m is minus 1. Okay, so what we've done is we've deduced what the function is for this graph.